we are to solve for the variable x. Because the x is in the exponent position, we call this equation an exponential equation. For the exponential equations in this class, we can follow the following 4 steps to solve them. Step 1 is actually already done for us. Notice it says we need to isolate the exponential expression. The part of the equation that has the variable is called the exponential expression. To put this another way, we need to get the problem to look like a constant, which in our case is the number 3, raised to some exponent, which should always have the variable in it, in our case it's just the letter x, and that'll be equal to some other constant, which in our case is 29. I call it some other constant because 29 is not the same thing as 3. So you have a constant raised to an exponent equals some other constant. Step 1 is already done for us, so we can move on to step 2. Step 2 is to simply take the natural log of both sides. It turns out you can use any logarithm of any base for this step, but for my class I'm always going to choose to use the natural log. But we would get the same answer if we were to use a log base 10 or any base logarithm for that matter. So taking the natural log of both sides literally is writing exactly what you see here and then simply inserting the left hand side of the equation in the parentheses and inserting the right hand side of the equation in the parentheses. I took the natural log of both sides. The reason to do this is because logarithms have a special property that if you have the natural log or any logarithm of a base raised to an exponent, that exponent can actually be moved down in front as multiplication and it will no longer be an exponent. This gets the variable out of the exponent position. In fact, we will no longer even have an exponential equation. That's the whole point. So doing this would look like this. The x came down in front as multiplication. What I've just done to go from here to here is what I'm going to call step 3. After we did step 2, by taking the natural log of both sides, it's now time to do step 3. The order in which you do the steps is important. Step 3 now says, if the base is e, use this property. Our base isn't e, our base was 3. So if the base is not e, that's this problem, our base was not e, it was 3, move the exponent down as multiplication. We just did that. So that was step 3. Now, step 4, being a little vague, just says solve for the input variable. The reason I don't give precise directions here is because at this point in the class, you already know how to solve this kind of equation. We have some number times a variable equals another number. To solve this, you would do to this exactly what you would do if you had a linear equation such as 5x equals 7. You would simply say the 5 is being multiplied, you would divide both sides by 5. That's what's going on here, except this just isn't the number 5, and this over here isn't the number 7, but it's the same structure. You have a number times x equals a number. So what I'm going to do is take the left-hand side of the equation and the right-hand side and divide by the natural log of 3, since the natural log of 3 is being multiplied by x. Then I would have the natural log of 3 divided by the natural log of 3, which simplifies down to be the number 1, so I'd simply have x equals this number here. This answer is considered an exact answer because I did not use a calculator and there's no rounding involved. If you wanted to find an approximate answer, not an exact answer, that would involve using a calculator and rounding. So I would type the natural log of 29 divided by the natural log of 3. When I press enter, the calculator already is rounding my answer to 9 decimal places. The real answer goes on forever. The fact that the calculator only displays 9 digits means this is no longer an exact answer, it is simply a rounded answer. Sometimes you're asked for an exact answer, and sometimes you want an approximate answer, for which you have to use your calculator. Now that you know how to solve a simple exponential equation, try a few problems on your own, and then move on to a more complicated example.